mitigating enteric methane and what could be the consequences of drastically reducing a really essential cycle in the rumen. We're very focused on hitting those targets, reducing, and coming up with really innovative ways to do that, but we might be missing some of the down the road consequences. For example, how that interacts with protein metabolism in the body.
Well, welcome to the Clear Conversations podcast. We're excited you're here with us today. Today we're going to be talking about cows and nutrition and sustainability. They are all tied together. They're all connected. And our guest today is Kelly Nichols. She's an assistant professor of animal science here at UC Davis. Welcome, Kelly.
Thanks for having me. Great to be here.
Thanks for being here with us. So first of all, tell us a little bit about yourself, your background, and how you got to study dairy nutrition in particular.
So I'm a dairy nutritionist. I'm from Canada originally, didn't grow up with dairy cows. I actually grew up on a horse farm, so still always knew kind of the realities of taking care of large animals 365 days a year. At first I thought I wanted to be a vet, but when I went to the University of Guelph to do my undergrad, that's where I started to get involved in research projects. And one of the labs I worked in was a dairy nutrition and metabolism lab. And you combine that with some of the courses I was taking, and I really fell in love with ruminant metabolism and how nutrition can influence how all of the metabolic pathways work in particularly dairy cows under the condition of lactation. So that's what I really got interested in. I ended up going to grad school, so I did a master's at the University of Guelph, and then I had the really cool opportunity to move to the Netherlands to do my PhD at Wageningen University, which is kind of like the UC Davis of Europe, you could say. So actually, they're often competing a little bit in the world rankings around things like environmental science programs, agricultural science programs, both super top in those areas. So I lived in total over there for 10 years. I did my PhD, and then I worked in industry for the last 5 years for a company called Trow Nutrition in their research and development ruminant research team. So I have kind of the academic background with some industry experience, and then I joined the animal science department here in March 2024. So what is that, a year and a half?
Yeah.
I've been here.
Excellent.
Yeah.
Excellent. Well, you touched upon it there. Tell us a little bit about your time in the Netherlands and how they're dealing with cows and the climate. Very small country, but a lot of livestock, and they're dealing with it in some interesting ways.
Yeah, so indeed, the Netherlands is a very tiny country, and there's a lot of livestock. So that kind of poses an interesting challenge. It's very dense with agricultural animals that are producing manure on a very small land mass. And like everywhere, that manure can be very useful for being spread on the land and fertilizing crops. And that's fine, but when the amount of manure and the nutrients in the manure, like nitrogen and phosphorus, starts to exceed the boundaries of what the land can really manage and use efficiently, you start to get impacts on the environment. So this has been happening in the Netherlands already for years and years, long before I lived there. And they've done a few different iterations of legislation to try to regulate how much manure, or more specifically on the nitrogen side, the nitrogen in the manure can actually be deposited on the land for a farm. And over the years, there have been a lot of changes to that, and a lot of that's been driven by measured negative impacts of nitrogen on nature preservation areas and other environmental impacts like air quality and things like that. And when I moved there in 2014, they had just had kind of a new wave of some of these changes to nitrogen-related regulations that were starting to put even more pressure on farms for the amount of nitrogen that they could put on their land. So that really kind of restarted some of the discussions around, at least in my area, particularly what can we do to support dairy farms to reduce the amount of nitrogen in their manure. So that's the type of projects that I was working on when I was over there, and still currently in the Netherlands. There's and a lot of other kind of northwestern European countries like Ireland, France, are all dealing with these issues where farmers are being pressured to reduce the amount of nitrogen or phosphorus that they're putting on the land, which can have some restrictions on how they manage their farm, how much milk they can produce, the financial sustainability of their operations. So there's also been a lot of tension. between government, farmers, society, and you read about some of that stuff on the news as well, farmer protests, tractors in the streets, those types of things. So it's been a contentious issue over there, but possibly a good example for other parts of the world as well that haven't experienced quite as much intense legislation around nitrogen pollution, but potentially that's something that could be coming. So it's something to think about even over here in the US.
And speaking of that, you did talk about that at our State of the Science Summit this past spring. You mentioned you're like, I'm not into methane as much as I am into nitrogen. Am I in the right place? But you and Dr. Maggie Gill talked a lot about it, and you said, methane was the headline issue, but the deeper story might be the cow itself and the physiology and the biology. Mm-hmm. Can you talk a little bit about what you meant by that?
Yeah, so methane has been getting kind of the star of the show, certainly here in California for extremely good reasons. The longer I live here, the more I've learned, through the Clear Center from Dr. Mittlener, all of the amazing things that have been done, particularly in this state, really leading the way for solutions to reducing methane in ruminant production systems across the country, and that's great. I'm heavily biased, of course, but I actually think nitrogen in particular is a much more difficult problem to solve than methane. It can change a lot in the environment. There will never be an inhibitor the way that we talk about inhibitors for methane in the rumen. So there's some different challenges involved with that. And to bring it back to your question about kind of the whole cow, we know very well the pathway that leads to methane in the rumen, microbes, fermentation, et cetera. Nitrogen is an essential component of, it originates from cows consuming protein, which they need to make milk, and they need to grow, and they need to be able to have healthy reproductive cycles, healthy immune systems, all of those things. So to find the balance of all of those systems together while supporting them with protein in their diet, that's also a big challenge. So I think one of the points we wanted to raise with that talk at the summit was just that we tend to get a little bit of the blinders on when we look at mitigating enteric methane and what could be the consequences of drastically reducing a really essential cycle in the rumen that we just haven't considered yet. We're very focused on hitting those targets, reducing, and coming up with really innovative ways to do that, but we might be missing some of the down the road consequences, like, for example, how that interacts with protein metabolism in the body.
Mm-hmm. And to that degree, you talked a little bit about you used the metaphor of the brain being like the conductor of an orchestra. I thought that was really interesting. You and Maggie talked about that. And the organs are the different sections of the orchestra. And kind of that gut-brain axis of the gut and the brain talk to each other a lot. I saw something one time, they said the gut and the brain are like besties. They talk about everything, whether it's emotional or physiological. We don't know that much about the gut-brain axis in ruminant animals in particular. Why is that?
Yeah, so I have to shout out Maggie for that whole concept. That was really her idea when we were given the mic for 30 minutes to talk at the summit. And she's like, okay, how are we going to do this? Let's sort of structure it in that way, and then we can probably touch on a lot of relevant points. So that idea of the brain-gut axis, of course, in humans now, for many years, actually, the research has there's been a lot of research focusing on the relationship between the gut and the brain and how that impacts our physical health, our mental health, and that's been an area that's just exploded over the last years. When you look to animals, there's far, far less in the literature, perhaps in companion animals that's starting to grow, which makes sense, I think, because of how closely connected humans and their companion animals are, that would be the next step for that research. But in livestock species, there's very little. So it is just an interesting thing to think about when we're talking about so the microbes in the rumen, it's this symbiotic relationship with the ruminant animal. We say we feed the microbes. We don't really feed the cow, we feed the microbes, and they've got their own little biological system going on there. So how that relates to all of the systems in the body, including the neurological system, which is sort of controlled and conducted by the brain. That's something that I think got a lot of people thinking. Who knows where that goes or how relevant that might be, but it definitely piqued some people's curiosity.
Yeah, it's just an interesting way of looking at it that maybe we haven't thought of before.
Yeah, and underscores how everything is connected, at the very least, trying to come back to that idea of you can't think about methane mitigation in a vacuum. Everything is connected. Right. Yeah.
Well, let's talk a little bit about your research and what you're doing right now. Tell us a little bit about that, because it's very interesting.
Yeah, so as we've made pretty clear, I'm a nitrogen person. Since I've been one of those fortunate people that since I started grad school, I've always focused on the same area. That doesn't happen for everyone. Some people kind of flip-flop around until they find the thing that really suits them. But I started out working in protein metabolism in dairy cows, and that's still very much what I work on. There's a lot of different research lines within that. So my program here at UC Davis focuses on a couple of different things, but one of the upcoming projects that we have is looking at what we call urea recycling. Mm-hmm. So ruminants, all animals have the capability to do this. But urea is a product of nitrogen metabolism in the body. So when we consume protein, we digest and absorb those amino acids. And then when those flow to the liver, some of the ones that don't get used for productive purposes, they get broken down. And sort of the waste product of that is urea. And ultimately, that can get excreted in urine. But ruminants are very efficient at a process that we call urea recycling, and that's because of the rumen. So some of that urea actually gets recycled back into the rumen, where the microbes can break it down again and use that nitrogen to grow. And then the protein in those microbes actually provides the majority of protein supply for the cow. So you have this cycle where you have kind of like the excess nitrogen gets used again to make valuable protein or amino acid sources for the cow. So in growing animals, we have this pathway characterized in way more detail. There's not a lot of literature on how this works in lactating dairy cows, and if we could potentially use that as a mechanism to reduce the amount of nitrogen that's going out in urine. So kind of repartitioning some of that urea from urinary excretion, which ultimately ends up as manure, which leads to this problem of extra nitrogen in the environment. If we can kind of upregulate that recycling mechanism and have it contribute back as real usable protein, maybe there's a way to reduce some of that excretion. But the problem is we don't know a lot about how that cycle responds to different sources and amounts of protein in the diet. So the experiment that we'll start in a couple of weeks will focus on that. So we'll look at the different sources of protein supply in the diet and how that impacts that cycle of urea recycling in lactating dairy cows. Because like I said, we know more about how that process works in growing cattle, so like beef cattle, for example, but not a lot about it in lactating cows, and their diets are very different. Their metabolism differs a lot. You have the mammary gland in there. So there are, I expect, differences, and this will be a study that will really start to crack some of that open.
Interesting. How many lactating cows are you going to be studying?
Yeah, so we have 8 cows. They're cannulated, so they're the ones that we can access the rumen, and we will be doing it in a very controlled way where we really precisely infuse an amount of protein into the rumen and an amount into the second part of their digestive tract, which is just past the rumen. So we can control very precisely how much protein is going into each compartment of the gastrointestinal tract, and then be able to say very clearly what the response is in that urea recycling mechanism. So it's a very fundamental metabolism study, but often you'll find in nutrition research, you kind of have to start there, and then you build out into what would really be used in practice.
Right, right, because it's a full system, obviously. You're testing the room, you're testing this, but then the full impact on the other organs and whatnot too, I would think you'd have to look at and figure out.
Exactly, so with a small number of animals, we can take a lot of measurements, try to get this whole full body picture, which we might not be able to do if you're using a feeding study where you have, say, 60 animals versus 8 in a really controlled environment. Yeah.
And so you spoke about it a little bit there, but the real world impact, how could this impact the real world?
Even though this is a very fundamental design of an experiment, it is still based around what we do in practice. So in reality now, dairy nutritionists, we're kind of past the idea of how much protein do dairy cows need, which that used to be a question years and years ago. Do they need a diet that has 14% crude protein or 20% crude protein? What's better? That's a really extreme example. But now we've sort of evolved from that through science, and now the question for dairy nutritionists in the field is more around what is the source of that protein? So is it protein sources that are more degradable in the rumen, or that actually are more resistant to microbial degradation and end up in the small intestine to be absorbed as amino acids there? How can they use those different sources to manipulate how efficiently that protein gets used? Those are the types of questions that nutritionists really care about now. So the way this experiment is designed is to answer this question about urea recycling based around the source of protein. So even though it's very fundamental in its design, the takeaways can be pretty easily applied in the field in the sense that, okay, when we put more protein in the rumen, this was the response. If we provide more of that source that actually bypasses rumen degradation, we get this response. So it's not actually that many steps before you could start to make some recommendations. Yeah.
How exciting.
Yeah.
This is exciting.
Yeah.
How exciting is it for you personally to be part of a study like this and to do this research?
Yeah, well, I'm super excited about it. This will also be my first big trial here at UC Davis. So I'm really proud of our team, my grad students who've just started. We're renovating a facility here to be able to do this research. So over the past several years, there hasn't been a lot of individual animal, really intensive metabolism work. But we do have a facility just across the road here that has been a bit underutilized. So we're currently working on some renovations there to be able to house up to 10 cows in individual pens and do these types of really detailed measurements of individual feed intake, milk production, having animals being easily accessible for sampling, things like that. Looking at everything that goes into the animal, everything that goes out of the animal, and really understand a lot about what goes on in between.
Yeah, right.
Yeah. So I hope this will kickstart a nice extra line of research for us over the coming years.
Yeah. And you spoke about it there about research too, and you mentioned it at the summit this past spring that there are still a lot of questions when it comes to cows and nutrition, and that's okay. We've answered some, but there are a lot of questions out there still to be answered, which is exciting for researchers and for future students and researchers to answer some of those questions. I guess the question is, where do you see the future of this sort of research going? Do you see it going in a certain path, or do you have any hopes for where the research might go?
Yeah. So, I mean, we always have hopes and big, what seem like crazy ideas now, but I'm sure that's the same thing that, my mentors said years ago when they started their careers. Like, these are probably crazy ideas, but now that's the reality, in the industry. Yeah, in this area, I think what's coming down the pipe is starting to get way more information about what, in terms of protein supply, really what are the amino acids that are available for absorption for ruminant animals. And that has been, for a long time, a question that's been a bit hard to get at in an easily accessible way. You needed these intensive metabolism studies to be able to quantify that, which is difficult when you, in reality, have a really diverse set of diets across countries, different regions of the world, even different regions of a state. How do you capture all of that variability by taking samples that are easily accessible that you can do across a lot of animals? And I think that's an area that me and some collaborators are starting to work on for the future to help optimize nutritional models, help have a better understanding of the response to a nutritionist making a particular choice about one ingredient versus another in terms of the efficiency with which the protein in that ingredient is going to be used from milk or muscle, whatever the case may be. So that's really exciting. I also thinking about the impact of early life protein nutrition on later life nitrogen efficiency is a really interesting area. There's abundant calf research that goes on. There's some really expert calf research out there starting to look at nutritional profile for calves. Over the last several years, protein is an area that I think has been under evaluated. And then what is the impact on calves being fed a certain profile of protein source or level? Does that impact how efficient they are using nitrogen in later life? That's one of those like big crazy types of questions. So that's something I'm interested in. So those are some of the areas that hopefully my lab will tackle over the next couple of years.
That's exciting.
Yeah.
That's really exciting. Anything I didn't ask you that you want to add about the research going on here and your time at UC Davis? Thank you for coming to UC Davis. We're excited to have you.
No, it's been great to be here. I think this is a good place to be for this nitrogen question. I know when I met Frank a couple years ago now, during my interviews and things like that, when I was thinking about coming here, he was very adamant that nitrogen would be a problem here in California. It's already a problem here in California, but that the fact that if we kind of lead by example with methane, there's no reason to think that we couldn't do the same in terms of the nitrogen problem as well. So I'm happy to be in a place where I came from, a place where that was really relevant, that being the Netherlands and Wageningen University, to another area that it's relevant, and then to be at the place where already has a strong reputation of making an influence on the dairy industry in the state, and then by extension the country. That's special. So,
well, there's a lot of research to still be done, and we're excited you're part of the research here at UC Davis. And thank you so much for joining us.
You're welcome.
And sharing your knowledge with us.
Yeah, of course.
Thank you for joining us. We'll see you again next time on Clear Conversations.